Hey, good morning, everyone, and welcome to our subject, Principles of Steel Design. And this will be our introduction for this course. Okay, so for at the end of the session, here's our outline and outcomes. First is to introduce to you what is the meaning of structural design, what is the design procedure, how does design works in the real world. Okay, and then to differentiate to you the building codes and specification, and then to discuss what is the behavior of structural steel when it is loaded. Okay, so at the end of the session, here are our hopefully our takeaways. Number one is to explain what is structural design and how it is applied in steel structures, and to describe the behavior of structural steel upon loading. Okay, so let's start. So as an introduction, we have here a definition of structural design. So it is stated here that structural design may be defined as a mixture of arts and science, combining the experienced engineer's intuitive feeling for the behavior of a structure with a sound knowledge of these following topics. Okay? Mainly, ang goal ni structural design is to attain three things, no? So to produce safe, economical structure, and a structure that will serve its intended purpose. Okay, so as engineers, we have three areas na kailangan i-assure, no, when we are constructing or designing a structure. Ang most important is to produce safe, no, structures, or yung life safety of our users or inhabitant ng structure natin. So we have to prioritize that our structure can withstand any forces that may be subjected to it without harming or eliminating the life of our users. Okay, and then next is serviceability. So we need to design structures to be able to be useful dun sa mga intended users natin. So if ever we design a structure intended for um, dwelling or for residential purposes, it should be easily used by our user as a place for their families. Okay? And then last is yung economical economy natin. So our goal is to design our structure to the most efficient way, no? So ito yung gusto ni client, no? Once our structure is more affordable or more economic, yung economy is there, definitely our structure will be more appealing. Pero siyempre hindi dapat mabawasan yung tibay ng structure natin when we talks about economy. Okay? And then we try to explain further, no? So structural design, sabi natin, mixture of arts and science. So it's a mixture of arts and science. Art in a way na as engineers, we are tasked to check whether the assumptions of our architects are within the limitations that's set by codes and standards. Okay, so let's say, for example, the dimension of our beam is given by our architects, but unfortunately the given width is not conforming to the minimum required by the code. So it is our job as engineers to explain to our architects that this dimension cannot be applied to our structure. So we it's an art because we are also trying um, to satisfy the designs of our architects, but maintaining as well the integrity of our structure. And then of course it's a science because it involves numerous calculations to be able to assure that our structure can um, carry the loads that it will be subjected to. Okay, and then we try to define also what is design. So design is a process by which an optimum solution is obtained. So meaning when we talk about design, we try to get several options or several recommendations for our clients or for our um, owners, and then we try to check what is the best option for them. Let's say, for example, you are tasked to choose between a steel material or a concrete material. So you should be able to demonstrate what is the advantage of using a steel material, what will be its depth, what will be its dimension, and then to compare it with its concrete counterpart on end to explain what would be the benefit of choosing one material over the other. So design also is finding for optimum solution, because once we start tackling the design part of our course or the analysis part, we will try to get different, or we will try to check numerous sections, still sections, for the given loading until we satisfy all checkings or design checks that we need uh, to pass. Okay, so it is a iterative process in a way that we are trying to um, follow what is stated on the minimum requirements set by our specifications. Okay, then we try to also to explain what is the design procedure in general. So this is an example or a simple example of the flowchart of what happens really on site. Okay, so when we say design procedure, it may be composed of two parts. We have the functional design or structural framework design. So let us refer dun sa flowchart natin. So looking at this flowchart, the design procedure or the construction generally, eh, is um, can be tracked using this flowchart. So it all starts with planning phase. Okay, so in the planning phase, sino ba yung um, usually involved or professionals involved? So syempre, si client as the one who decides or who finances our project, and then usually si architects talaga yung kasama sa planning phase. Also, kapag halimbawa massive yung structure natin, si architects yung kailangan kasi they know the requirement for a specific structure, no? So when what are the clearances required, what is the occupancy or the requirement by the building code. So sila talaga yung mas nakakaalam nun, no? So usually the planning phase between architect and si owner. Pero minsan if the structure or the project is not so massive, and of course we as engineers also have a background of how to start, no, yung design, we can also be included in the planning phase. But for me, I believe na it's more appropriate if the architects are the one who who are involved dito sa planning phase. Okay? Then once the drawings or the preliminary drawings or specifically architectural drawings are prepared by the architects, papasok tayo sa preliminary structural design. So preliminary structural design, this is where we verify, no, if the assumptions made by the architects are pwede, no, or acceptable. So it does not mean na we should check it right away, but experience will tell you. For example, you're doing a project for the end time na halimbawa residential building siya, tapos pang 10 mo na siya. So you already have a feel of what will be the dimension of your members. So sa preliminary structural design, you are able to assume already what will be the behavior or the right sections for your structure. So we can use that assumption to verify it later during the design process or the checking. Okay. Then after we have our preliminary structural design, we try to estimate our loads. Okay. So in estimation of loads, we go back dun sa basic knowledge natin in structural theory, or determining what are the components applied on our structure. So we have said, for example, we have a truss, So let's say we have a truss. Okay. So a simple truss lang. Okay. So then we have our simple supports, and then we try to identify what will be the loadings for our truss. So, as engineers, we have set of values that we can refer to. No, so going to our specification or the NSTP, National Structural Code of the Philippines, there are values in Chapter 2 that you can use for whichever material the architect has prepared dun sa architectural drawings na pinrepare niya dun sa planning phase. No? Then we try to extract what are included there. So let's say, for example, dito sa roof natin, we have purlins, no? So we have purlins installed on our top chord. And then right after our purlins, there will be a covering. Okay? Yung mismong covering ng ating truss or yung roofing itself. Okay? So based from the estimation of load, we should know how to transfer the load of the material from the exterior part going dun sa interior, dun sa innermost element natin. So dito, si covering natin, let's say a GI sheet or a clay tile, no? Yung preferred ni architect on his or her design, that load will be carried by our purlins. Okay? Then si purlins, that will be carried by our rafter or our top chord, and then eventually the loadings will be applied dito sa truss natin, and then we will now have an estimate of the loadings, no? So ano ba yung mga loadings natin? We have dead load, live load, and then our environmental loads. So that is the case kung bakit during your structural theory subject you have loadings like this, okay, or loadings pag ganyan, So those loadings are from the loadings attached dun sa top nung cord natin, and also from our lateral loadings or exterior loadings from our surroundings. Okay? And then after we estimate the load, we try to analyze it. And then when we analyze a structure, we try to identify the distribution of the forces for each member. Okay? So in structural theory, we are tasked always to find for the supported actions, and then we are also, from our mechanics subject, we also determine yung mga compressive and tensile forces existing dito depending on our condition dito sa structure natin na to, example structure. Na eventually, we try to distribute yung forces natin para malaman natin what is needed to be supported ng mga elements natin. Okay? Kaya doon nag-play sa structural analysis. Now, once we identify the forces, the moments, the shear, the deflections or the slope, no, ng mga structural element natin, dito na papasok yung course natin ngayon. In asking ourselves, are the structures safe and serviceable based from the requirement of the code or the specification? So this will be our task, no, in this course. Mainly analysis tayo or checking the capacity of our chosen member, and then comparing it with our actual loads. Okay, so later we will discuss the different checking for each component. So later, try natin verify, and our goal is to check or to satisfy all requirements, and then Once satisfied, we can now proceed with the construction drawings and eventually proceed with the construction phase. Okay, so if ever upon checking the component for the required checking based from the code, and then let's say it did not satisfy one checking, we need to revise our structural design. And then we will go back dun sa estimation of loadings natin. In estimation of our loads, we try to verify what assumptions we did wrong. Let's say, for example, when we assume for the live load, then let's say the occupancy, intended occupancy of your structure is for 3 to 4 people only, but you estimated for 20 persons. So your live load is overestimated. So that is why that may be the cause of your failure in your checking. So upon verification, you have reduced your live load. So eventually your shear, your moment, or your forces will reduce also. And then upon rechecking for the required checking based from the code, you will see that your component will now pass all the requirements. And then eventually will proceed to the construction phase of the um, project. Okay, so this flowchart actually is very general. It does not mean that as engineers you are tasked to do it all by yourself. In actual practice, we are composed of different allied professionals, no? So you have a project team that will work together each step of the way. So as engineers, we are just should know, no, what is the process, so that um, we will know what to expect during the construction phase. Okay, so if ever there will be problems during the construction, then we can consult the professionals that involved during the planning or the actual commencement of our project. Okay, so this is just a glimpse of what you will expect when you are doing construction works already or when you are on field. Okay, pero basically ganito lang yung nangyayari sa kanya. Okay, and then we go dun sa just to formalize it, no, the different loadings that we expect on our structure. It is said that the forces that act on our structure are called loadings, and it is classified in two broad categories. We have the dead loads and the live load. So when we say live dead load, so mainly this is our permanent loads. Okay, so the weights of our elements or components of the structure are considered dead loads. Okay, and then we have superimposed load or any attachment that will be placed on the structure permanently, so that are also considered dead load. Okay, and then we also have live loads. So the difference with live load is it's transient or not permanent. Okay, so we as people or inhabitants of the structure are considered live load because we are moving from time to time, and also our furnitures. Okay, so maybe next month you will move the furniture from one place to the corner. Okay, so the distribution of the loadings will be different. Okay, but again, live load is in general non-permanent loads. Okay, here's an example of how these live loads are distributed on our main components when it is applied in our structure. So um, maybe a review of your structural theory will help you um, determine how this works. Okay, but we will try to discuss this kind of distribution also when we start with the analysis and design of our components. And then we also have other loads that we can call environmental loads. So mainly wind load and earthquake. So in the Philippines, we do not cater yung snow load, which is prevalent also in other countries, no? But for us, we are more focused on wind load and earthquake. Especially our country is always subjected to number of typhoons every year, no? So wind load is um, very important to know. Okay? Pero depende pa din siya sa structure natin. So if our structure is located on a terrain that is open, ano? So more or less wind load is always present. Okay? But if it's located in a urban area, so madami ng coverings or factors na nag-a-affect ng flow ng air, ng wind, before it passed or it is subjected on our structure. So it will be different approach. Okay, but mainly we have environmental loads, wind load, and earthquake load. So in the NSCP, there are available figures for us to determine what is the maximum loading or expected wind velocity that can happen on a certain site. Also, for earthquake, there are acceleration maps included on NSCP for us to have a assumption for the acceleration or ground motion na pwedeng mangyari when an earthquake happens. Okay, so these are the 4 loads that typically we use, no, when we try to design structures. Okay. Then next, we try to differentiate building codes from specification. Okay. So buildings must be designed and constructed according to the provisions of a building code. So si building code is a legal document containing requirements related to the structural safety, fire safety, plumbing, ventilation, and accessibility to the physically disabled. Okay? So mainly si building code is a set of minimum requirements set by local authority which should be followed when we try to construct new structure, halimbawa. Okay? So let's say you are trying to construct a structure. Let's say this is your let's say this is your lot plan. Okay, then according to the building code, you should have an offset dun sa front and then sa rear and then also sa sides. Okay, so meron section in sa building code na dapat when you try to attach your structure on one side, you should install a firewall, no, before you construct your structure. Okay, then you also have different requirements for the offset on front, at the end, at the side. Okay, so all of these things are indicated dito sa National Building Code kasi it promotes safety. Okay, so the firewall is for fire safety so that the adjacent building will not be affected when a fire happens. And then other requirements, let's say what I have said earlier, yung mga minimum clearances natin. Okay, so nandyan po yan nakalagay sa National Building Code. And more or less, si architect, ito yung alam na alam nila by heart. Okay, so tayo in building design subject natin, we try to review what are the minimum clearances, okay, the spaces that we need for a specific area of the structure. Let's say sa bedroom, ito lang yung pwedeng size, ito yung minimum dimension. Sa CR, ito yung minimum area na dapat meron tayong CR. So here in the National Building Code, it is specified yung mga minimum distances. Halimbawa, si water closet sa CR natin, the distance it should have from the wall, it should not be beside a wall, no? Dapat may certain distance yung center ng water closet from the wall. Okay? And also our shower head, yung height niya. Okay? So all of those things are included here. Okay? Of course, also yung mga requirement for our PWDs. Okay? So let's say yung mga ramps required to consider para maging accessible sa PWDs yung ating structure. So it's all stated here sa National Building Code. So there's a specific note here that building codes do not give design procedure. So walang design procedure. They just give the minimum requirements. Okay? So they specify the design requirements and also yung mga constraints or yung limitations natin on our building that must be satisfied. Okay? So yan yung inaano natin. So walang step by step kung ano yung gagawin mo dun sa structure, but the minimum requirements set by local authorities that should be followed are all indicated in this code. Okay? And then when we go or when we try to compare with design specification, this type of documents or publications are more specific, no? So they give the checkings required that we are discussing earlier dun sa after ng structural analysis, no? So sa design specification, these are the one who set what needed to be satisfied. Let's say sa design requirement natin, anong capacity yung kailangan nating required strength na kailangan natin ipasa, okay, on a certain component that we are trying to design. Okay, so design specification represent what is considered good engineering practice. Why? Because these specifications are being updated rigorously, no? Especially when a calamity happens. These specifications are always updating. Let's say, for example, a strong earthquake happens on an area, and then mayroong mga new faults na nag-appear. So kung may new faults na present, the maps available on this specification should be updated para if ever we are trying to design future structures that may be located on these fault lines, we are able to consider what are the loadings that needed to be applied as part of our analysis. Okay, so let's say for example here in the Philippine setting, we have the NSCP 2015. Okay, so the latest is 2015 7th edition, second printing. That is the latest one, second printing. So in this publication, the wind load are adjusted based if you try to compare NSCP 2010, there is a update for the wind load because of what happened during Typhoon Ondoy, no, and Yolanda. So they increased the velocity, the wind load velocity values, and then try to update the values on each areas, no, on each region. So they try to update it so that when this type of typhoon happens again in the future, our structure can be able to withstand it. No, if not withstand it, at least not collapse. Our structure will not collapse as the wind pass through or the heat as the wind hit our structure. It will not collapse right away. It will give a fair warning for our inhabitants to evacuate first, and then the life safety of these inhabitants are secured. Okay, so you will expect na in the future these codes will continue to update because research are also conducted always to make our life easier, no? So the materials stated on this specification are also updated. Okay? So that is the difference between building code and design specification. Now we go dun sa structural steel natin. So we go back with the demonstration of a steel bar, no, that we already discussed, or you should already discuss during your mechanics of deformable subject. Okay, so let's say we have a steel bar here subjected to tensile forces. So we try to pull the bar that we have. So once a force is present acting on the cross-sectional area of our body, it is understood that we exhibit, or the material or the body itself experience stress. Okay, so from our strength of materials or strength of deformable bodies, we have stress is equals to load over area. And then as our material lengthens or elongate, we have a change in length. And then we define the change in length over the original length as strain. Okay, so change in length over original length. And this two property of material, the stress and strain that the material experiences when loading is applied, is plotted against each other. Okay, so we have here what we call the stress-strain curve or stress-strain diagram that was observed previously by scientists. No, then they try to plot the behavior of the material when the load is increasing. Okay, so looking at this diagram, okay, so they put yung stress dun sa ordinate natin, and then yung ating strain dun sa abscissa. Then when loading starts dun sa material natin, it was observed by Robert Hooke before, no, that at a certain time, as the load is being increased, no, so the stress is increasing, the strain is also increasing. Okay, and there is a point wherein this increase is proportional. We have a linear relationship between the stress and the strain. So that is the limit identified by Robert Hooke as the proportional limit. So from the start of loading, or from zero loading up to the proportional limit, there exists of what we call the Hooke's law of elasticity, wherein sabi doon sa Hooke's law, okay, so sa Hooke's law, sabi niya is the stress is proportional with our strain. So introducing yung constant of proportionality natin, we have here K that we can call as the modulus of elasticity. Okay, or also known as the Young's modulus of the material. Okay, and rearranging our formula, we can get that the modulus of elasticity is equals to the ratio of the stress over our strain. Okay, and sometimes this modulus of elasticity, or always, no, is represented by E. Okay, so they just change yung designation of K to E to represent yung modulus of elasticity of the material. So for this case, yung steel natin. Okay, it is said here that the modulus of elasticity is the ratio of our stress and strain. It is also the slope, identified also as the slope of our linear line. So ibig sabihin, dito sa linear portion or sa proportion na part ng ating curve, doon natin ma-identify si modulus of elasticity. So meaning, Hooke's law only applies within this limit. Okay, so up until the proportional limit, linear yung relationship ni stress and strain. So once we try to increase our stress a little bit further, or outside the proportional limit, the stress will now behave differently from strain. Okay, until ma-reach natin si elastic limit. So before we reach yung elastic limit, the behavior our material is that when we unload or we try to remove yung loading natin from the material is going or reverting back or going back to its original shape. That is before the elastic limit, because we are our material exhibit elastic phase. Okay, so once this elastic limit is reached, our material will no longer return to its original shape. So it will inhibit or experience deformation, permanent deformation. So let's say for example dito, when we apply P and then it has a elongation na to na delta L. Once na hindi pa na-exceed sa elastic limit, our material will go back to its original shape. Okay? Pero once na na-exceed sa elastic limit, the deformation present on our material will not be reduced, no? Or it will become permanent na dun sa material natin. Okay? So, after elastic limit, our material will experience permanent deformation. And eventually, our material will experience a point wherein it is a higher value than the elastic limit, then eventually go back to a point wherein a constant value of stress will be present on our material. Pero as the stress is constant or hindi na nag-i-increase or there is no increase in stress, there will be a further increase in strain or continuous elongation dun sa material natin. And this elongation, typically 12 times from the time na nag-yield siya, no? This portion is what we call yung yield point natin, no? Yield point natin. This is the location we're in. Yung material natin is possesses constant stress or constant loading, pero with continuous elongation. So, nagpa-plastic yung behavior niya. So, ibig sabihin, kahit hindi tayo magdagdag ng loading sa kanya, patuloy ang pag-stretch ng material natin o pag-elongate ng material natin. Okay? Then eventually, when it reaches the end or its plastic range, the material will receive or will continue to be subjected to stress or to a load na ma-attain niya yung highest point niya, yung pinakamataas na value niya na stress, the highest value of stress that possible do sa material natin, then eventually it will fracture. Okay? So, meaning it will elongate, but it will try to sustain continuous stress and strain up to this point. Then eventually, when our material is at plateau na, no? So, meaning nasa highest portion na siya, it will now lessen its value, not eventually mag-break na siya dito. So, it exhibits what we call necking. Okay? So, as you can see dito sa ano natin, when our material is being pulled by the machine, okay, or tensile forces are applied, the gauge section or the observation length that we have in the material, okay, nagre-reduce yung area niya. Okay, then once na-reach niya yung highest point niya, necking appears. Okay, when necking appears, what happens? There is an impending failure or snapping dito ng material natin. Eventually, mag-snap siya or magiging siyang two pieces. Okay? Then when that happens, when that failure happens, this is this point, the fracture. Okay, what we call fracture point. okay, or necking and failure of our material. Okay, so this is the main curve for our material that we will cover on this course. Okay, so there is also another figure for that na medyo para mas maintindihan natin, ano? So same figure, so starting from the origin up to the proportional limit wherein dito again we have a linear relationship between our stress and strain, meaning um, an increase in strain will result as an increase in strain, a decrease in stress will result as a decrease in strain. Okay. After that point, we have the elastic limit, wherein beyond this point, our material will now experience permanent deformation. Okay. So if our material is not yet reaching this point, the material will still return from its original shape, original length. Okay, then after that, we will reach the next point, or what we call the yield point, wherein that is a point where there is a permanent value or constant value of stress, then continuous increase and elongation. So nag-elongate siya, or yung strain natin is there. Then after yung yield point, the material will have strain hardening. As the strain hardens, the stress will increase up to a point na tinatawag nating ultimate strength, wherein this is the highest stress that the material can carry. Okay, then eventually it will fail, or it will necking will appear, then eventually it will collapse, or it will snap into two objects. Okay, so as you can see here, we have yung actual strength and we have yung nominal strength. Okay, actual strength is increasing, actual rupture strength is increasing dahil once na necking occurs, what happens? Our area becomes smaller, and according sa formula ni stress, our area is a divisor, and when the value of A decreases, the value of stress increases. But here in our test, we consider what is the nominal area, or the original area, cross-sectional area of our material. That is why on this value, this point is called the nominal fracture strength, or nominal rupture strength of our material. Okay, so that is what we need to know, to be able to understand better our material, or yung structural steel na gagamitin natin on our next topics. Okay? So to reinforce this, we try to solve a sample problem with regards with stress-strain diagram. Okay? So we have here an example problem. During a stress-strain test, the unit deformation, so when we say unit deformation, we talks about strain. Okay, the unit deformation at a stress of 35 meganewton meter squared, so that is also equivalent to megapascal, was observed to be 166.67 times 10 to the negative 6 meter per meter. At a stress of 140 megapascal, it was 666.67 times 10 to the negative 6 meter per meter. If the proportional limit is 200 megapascal, questions are: what is the modulus of elasticity of the material, and what is the strain at 80 megapascal? Okay, so to start solving this, let's have our calculator as our help. Okay, so given tayo ng two points ng stress strain diagram. So we have our first stress is 35 megapascal. Meron siyang strain of 166.67 times 10 to the negative 6 meter per meter. Then we have another stress valued at 140 megapascal, and then strain of 666.67 times 10 to the negative 6 meter per meter. Okay, then we have a proportional limit of 200 megapascal. So to solve this problem, we need to plot first our stress strain diagram. Okay, so this is our stress strain diagram, our ordinate or stress, and then we have our uh, abscissa or strain. Okay, so this is our stress, our strain. So in plotting, we try to scale it as much as possible. Okay, so we have let's have this by 20. Also 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Okay, and then we have here 100, 200, 300, 400, 5, 6, 7, 8, 9, 10. Okay, so our abscissa or our x coordinate is multiplied by 1 raised to negative 6, and then here is we have increment of 20 megapascal. 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Okay, plotting our first 35 megapascal. So 35 megapascal is halfway. And then we have 166, so somewhere here. So we have this point and this point. So our figure is assumed only, no? So you can use ruler to better plot your points. Then second point, we have 140. So this is that point. Okay, 140. Then we have 66. So 1, 2, 3, 4, 5, 6, and then 7. So halfway that value or beyond halfway. Okay, so this is our second point. And then our proportional limit is at 200 MPa. So at this location, this will be our proportional limit. So it doesn't say what point. Pero one thing is for sure, no? Beyond or right before nitong location ng stress of 200, ang proportional limit natin, we know that our stress strain curve is linear. Okay? Okay. Assuming that is a straight line passing through those points. Okay, so we have now our stress strain diagram with our proportional limit at this point. Okay. Now, we need to identify the modulus of elasticity of our material. And to get that, okay, so we will go back dun sa definition natin kanina of elasticity, wherein that is equals to stress over strain. And as observed here, our 2 points is below our proportional limit. So it follows Hooke's law of elasticity that the stress and strain has a linear relationship. So we can get actually the value of our modulus of elasticity by solving or using the values of our points. Okay, so let's have our first solution here. So considering yung ating point 1. Okay, so we have stress is equals to 35 megapascal. And then we have strain of 166.67 times 10 to the negative 6 meter per meter. Okay, so applying the formula, we have stress over strain, or 35 megapascal is also equals to Newton mm square all over 166.67 times 10 to the negative 6 meter per meter. So cancel out si unit na meter per meter. So elasticity is equals also to megapascal. And looking at our calcu, we have 35 divided by 166.67 times 10 to the negative 6. Okay, then equals. So we have 209,995.8 or roughly equals sa 210,000 megapascal. Okay, so that is our first solution. So when we try to answer the second point, so point 2, so it's equals to 140 megapascal, and then strain of 666.67 times 10 to the negative 6 meter per meter. We have E is equals to stress over strain. We have 140 megapascal all over 666.67 times 10 to the negative 6 meter per meter. Cancelled out unit. We have the second value of modulus of elasticity as, so 140 divided by 666.67 times 10 to the negative 6, we have 209,998.95 megapascal, or roughly 210,000 MPa also. Okay, so from here we can verify that modulus of elasticity may be indeed equal to 200,000, 10,000 MPa. Okay, so what else can we use as a verification for our answer? We can refer to our diagram. So our diagram is a straight line, okay? And as mentioned from the previous slide, we say that the linear portion of our curve corresponds to the slope of our, you can get the slope of our line, and the slope is equal to the modulus of elasticity. Okay, so what is the definition of slope from basic geometry? So slope is also defined as rise over run, right? So let me, okay. Let me show lang. Okay, yeah. So slope, so the modulus of elasticity is also equals to the slope, okay, which is rise over run. Okay, going to our figure, our rise is, or rise from one point to another point is this point, and our run is from the left point going to the right. Okay, so what is the value of that? So dito, this height is equal to 140, and this height is equal to 35. Okay, this length is equal to 666.67, and this length is equal to 166.67. Okay, so looking at this figure, we can know what is the value of our rise and run. Okay, for our rise, that will be 140 minus 35, and for our run, that is 666.67 minus 166.67 times 10 to the negative 6. So unit is still megapascal. And here is meter per meter, which is cancelled out. So modulus of elasticity natin, when calculated, is so 140 minus 35 all over 666.67 minus 166.67 times 1 raised to negative 6. Okay. We have an exact value of 210,000 megapascal, which is the same as our answer from the two calculations we did earlier. Okay, so we can say now that the modulus of elasticity of the materials is indeed 210,000 megapascal. Okay, again, this formula is possible only within the linear portion or before the proportional limit of our curve or diagram is exceeded or below the proportional limit. Okay. Next question is, what is the strain for at 80 megapascal? So now that we have our modulus of elasticity, we now can use this value to look for the value of our second strain. No, given our stress of 80 megapascal, 80 megapascal is less than our proportional limit. Therefore, E is also equals to 210,000. Okay? Or therefore, it is nasa linear portion, no? Nasa linear portion pa tayo. So, it means that we can still use the formula for Hooke's law, wherein the stress over strain, or in this case, we are finding out for the strain, so strain is equals to stress over the modulus of elasticity. And then when we substitute, we have stress is 80 megapascal, and we have modulus of elasticity of 210,000 megapascal. Okay, cancel those out. We have a strain of equal to, so let's have our calculator. So we have 80 divided by 210,000. That is equivalent to, then let's divide it to 1 negative 6. So we have 380.952 times 10 to the negative 6 meter per meter. Okay, so this is our strain based from the formula. Okay, so once we try to verify, since 80 megapascal is between our first and second point, okay, between 35 and 140, it is safe to assume that the strain should be greater than 166.67 but less than 666.67. And what we got is 380, which is indeed in between of 166.67 and 666.67. So our strain here is correct, and this will be our answers for this example problem. Okay. So before we end, I will just try to share this idealized stress-strain curve. So we try to simplify the portion wherein there is a overcrowding ng points natin, no? So going back sa figure natin, this is that location wherein the proportional limit, elastic limit, and yield point coincides. Okay, so ideally, we can assume that it is located here. Okay, and this idealization, we call this portion or this level as the yield stress of our material as Fy, and then the highest point or the ultimate strength point is our Fu or ultimate stress. These two values, Fy and Fu, will be used always when we start analyzing and designing our components. Okay, so it is good to know the different the usefulness of these two values. Okay, and for structural steel, even though we are not given the value of E, it is always, or for all structural steel, the value of E is 200,000 megapascal always for metric, and for English system or metric or imperial units, that is 29,000 kips per square inch. So this is a constant value and will not change unless otherwise noted on the problem. Okay, so always 200,000 megapascal and 29,000 KSI. And then we also have here a diagram of high strength steel. So mind you, our steel earlier is for mild steel only, okay, which is the basic type of structural steel that we will cover for this course. So you see high strength is for specialty purposes, so we will not cover that. But to just show you the relationship of the points, as you can see, you will not be able to determine or to see a linear relationship. So Hooke's law of elasticity does not apply dito sa high strength steel natin. Okay? Pero when we introduce a residual strain or an offset dun sa strain natin, we can predict a position wherein magkakameron ng linear relationship dun sa high strength steel natin. So dito sa offset na to, dun sa residual strain natin, there is an imaginary line wherein we can determine the modulus of elasticity. Okay? And then eventually get whichever is the value of this point, okay, of this height, and then get the value of modulus of elasticity using the formula that we have introduced on the previous slide. Okay, so that ends our lecture for this module. So hopefully you are able to grasp whatever we have discussed. For questions, you can leave comments or ask me personally during face-to-face session. Okay, so see you guys again next module. Thank you.